said between 0 and 360, so we know we have degrees. We know we don't need the plus 360K because I gave you a stopping point. I didn't say all possible solutions. But what we do have to watch here, we have signs on both sides. It is not legal to just multiply or divide by a trig function if you don't know the angle. The reason being, if I just divided by sign, I will lose the solutions where sign is equal to 0 because you can't divide by 0. So don't divide on these. Instead, we get it on one side. And what can we do now?
Take out a sign.
So if we set them to 0, okay, when is sine equal to 0? If you think about your unit circle, sine is what?
90 degrees.
Mm-hmm. And 360. But 360 is the same as 0. So on this, because I put the bracket on 0 and parentheses on 360, although the same, we'll list it as the 0. This one says tangent is equal to 1. In what quadrants is tangent positive?
1 and 3.
Reference angle. When does tangent equal 1? So 45 degrees in quadrant 1 is 45. In quadrant 3, so 180 plus 45, 215. And we get all of our solutions. Is that okay?
Mm-hmm.
Let's So these are involving a combination of trig and algebra. We need our factoring techniques from algebra, but then when it comes down to solving them, we're thinking about the unit circle from trig. So this one, I don't have a greatest common factor. It's already equal to 0, but we did some of these when we were looking at identities. This is like a quadratic type. We have something squared, the same thing to the first, and a constant. So we could do slip and slide. And then we start out multiplying by 3, so we divide our 3. And so now we have successfully factored it. Now the reason we factor, if you have two things that multiply to 0, how do you find those things? This one, if we subtract our 2 and divide by 3, sine is negative 2/3. Now we need x. If you think about on the unit circle, sine is the y. When is y equal to 1? And we were in radians this time, so we'll leave it as pi over 2. And that is the only time on the circle that sine is equal to 1. Then we need to find when sine is equal to negative 2/3. Is that one we know?
Mm-hmm.
Okay. Quadrants. When is sine negative?
3.
So we have to use our calculator to get our reference angle, because we don't know when it's 2/3. So a few things. First, are we in degrees or radians?
Radians.
So put your calculator in radian mode. All right, second, we have talked about inverses. Did this problem start out as an inverse?
No.
No, so we're dealing with every time. But don't put the negative in. We talked about that when we were doing inverses on our calculator. So you need to do second sine for the sine inverse, but then do positive 2/3. So my reference angle is 0.7297. So let's think. If we want to be in quadrant 3,
The angle
Plus.
minus 180. Plus.
we would add, and we don't want to do 180 though.
Add pi.
So we'll do pi plus 0.7297. And that gives me 3.8713. What would we do for quadrant 4?
2 pi minus.
Now we do have some rounding error on these, so just be aware of that.
How'd you get 3487?
We did pi plus because it's bigger than pi, put it in quadrant 3, and this was 2 pi minus. Is that one okay? We don't have to put the plus like 2 pi k or anything because I just said for the solutions between 0 and 2 pi. If you wanted to check them, you could put them back in. The 2 decimals, they're not going to come out perfectly because we rounded, but it will give us something very close to 0 if you were checking. Alright.
How would you check that?
So you would,
Use sine inverse.
no, you would put it
Oh.
in as your x. So you would do 3 sine of that squared. But you have to make sure you square d. You can't put lightning. You would have to add an extra set of parentheses because we don't want to square the angle as much as square the function.
Would it have to be the same variable if we put it for x, would it have to be the same?
Yes. Other questions, sir? I'm going to go to this one next.
You make the distribute and then subtract and then undistribute.
Yes. So the problem is it's not equal to 0. It's factored, but if it's not equal to 0, that doesn't help. So if we distribute first, we get cosine squared x plus cosine x equals 2. Then we can subtract over the 2. And now we can refactor. So cosine squared gets into cosine.
One plus 15.
Let's multiply to a negative 2 and add to a positive 1. So we set these equal to 0.
Does it want me to degrees or
So I did fail to tell you if we were doing degrees or radians one. Let's do radians. If I say all solutions, what does that mean we have to do?
Just
A.
take.
Or 2K. Wait.
Plus
2
just
pi k.
2 pi k.
Alright, can cosine equal negative 2?
No.
No, cosine can only be things between negative 1 and 1. So this is impossible, so I just ignore that one. When is cosine equal to a positive 1?
0 and pi.
Just
Just 0.
0.
And
Pi is negative 1 though.
pi. Oh, whoopsies. Just 0. Okay.
Okay, but every time we go around the circle, we hit that again, right? So if I say all possible, since we're in radians, how far is it to go all the way around? 2 pi, and we do k for the number of times.
State.
This could we just write this as 2 pi k? Since 0 plus anything is that. I wouldn't really count it wrong if you said 0 plus 2 pi k, but we should recognize 0 plus anything is that. You do need to tell me that k is an integer, so whether you say that in words or use the symbols, we just can't have like a k of 1/2. Because then if you only go around half a time, you don't make it back to where you started and it
Is
wouldn't
the
work.
middle one like a C with a line?
It's a curved E. It means is an element of or is part of.
And then the last one is integer, right?
Yeah, it's a double bar Z means integer. Alright.
Sideways cantaloupe.
Oh, wait, can we just, cosine, or wait. Never mind.
We have 2 squares, but I don't know what it's called.
Can we change sine into cosine?
Okay.
Oh.
If I just try to factor this right now, is it going to work very well?
Mm-hmm.
I have 2 different trig functions. No greatest common factor. Since they're not the same function, we can't like do quadratics or anything like that. So our identities have to come back into play here. If we are thinking about that, we need to replace one of these. It does not matter which one. So which one do you want me to replace?
The sine squared.
Okay. What can I change sine squared to?
Cosine squared.
1 minus cosine squared theta. Right, because sine squared theta plus cosine squared theta equals 1.
Why can't we just make it equal cosine squared theta?
It doesn't seem for.
Because it would have to be a negative right here for that to work. That identity is cosine squared plus sine squared, so you would have to subtract it over. But if it did, if it was a minus, then that would absolutely be the fastest method. Okay. If I add my cosine squared over, I get 2 cosine squared theta equals 1 plus 1 is 2. What now?
Subtract 2 over.
Okay. So factor, we have a greatest common factor.
I did it the other way.
That's fine.
I know, but I wanted it to look like yours.
Probably could do it.
So it's just plus 1 minus 1, different squares.
Oh, no, can't do that, dude. Or would that be the same thing?
And then you just have equal.
Does 2 ever equal 0?
Nope.
No, so we can just drop that. Cosine theta plus 1 equals 0, that gives me negative 1. Cosine theta minus 1 equals 0 gives me positive 1. So, let's do degrees for fun. I said all solutions. So when is cosine equal to a positive 1?
0
And if I said all possible, we would have to say,
plus, so just 2 pi k, or, 360 k.
because I switched to degrees on you.
Yeah.
When is cosine negative 1?
180.
Plus 360.
And what do you need to tell me about k?
K is an integer. Is that under or someone just
Do those things.
dying?
Pretty sure.
It was raining earlier.
I got a baseball game too.
You didn't
Is
cancel
it
it?
actually
Yeah, it was raining very much.
Oh, I didn't even see it.
Where's your baseball game?
Bacon. But
Bacon.
they have a track, like
I
a
think they're
all
raining
weather.
baseball the track team.
Now, I just want to warn you. This answer could be written different ways. So how you have it is perfectly fine. But if you realize, here's 0, here's 180. So every time we hit this one, it's the solution. Every time we hit this one, it's the
You
solution.
could do 0 plus 180.
So isn't it just every multiple of 180 we're hitting it? So another way you could see this one is just 180k, every multiple of 180, we hit a solution. I don't care. As long as you have an equivalent form, I'm good with it. Just know if you're trying to check your answer in the back, they are going to go with the shortest way to write the answer.
Is 180k, it encompasses everything that we, all our solutions? We don't
Yes,
have to do two.
because like when it's 0, you get the 0. When k is 1, you get the 180. When k is 2.
Is it okay if I like just left the cosine on one side and then equals the 1 and then did the square root and put plus and minus?
Yep.
Isn't that perfect?
We factored it like a difference of squares.
What's that one called?
That's just the square root method.
That's just Carson.
All right, let's try some more.
It just made sense.
Subtract that.
All right, cannot divide the cosine. Instead, we subtract it.
No, we take it out anyway.
Now, you could certainly do some identities or something, but it's not necessary because we are able to factor this. We could take out a cosine, and that would leave us with sine squared theta minus 1.
Can we change that back into cosine? Or is it just gonna go to a loop? It's gonna go to a loop.
It would work. It'd be okay.
Are we doing, oh, it's okay, it's radius. This one says it.
So if we set them equal to 0, cosine theta equals 0. So cosine is the x. When on the unit circle is x 0.
Just on twice, it's up there and down there. 90 and 270.
But we're in radians.
So
2
it's
pi, well, pi over 2 and then 3 pi over 2.
I like to go back and forth every other question just to confuse you. This one, we do Carson's method, square root plus a minus, so sine is equal to a positive or negative 1.
It's the same thing.
When is sine positive 1?
No, add 90 and
Pi over 2. When is sine negative 1? 3 pi over 2. So it didn't give us any extra answers.
Oh, we didn't have to add. I did my add.
Yeah, this one just said between 0 and 2 pi, so we don't need the plus 2 pi
Can you
yet.
just pick a way to do
That's
that?
why cosine, replacing sine squared minus 1.
Yeah,
Cosine.
that's why it wouldn't matter on numbers.
Just myself.
Alright,
Do multiplicities not matter in this case?
they do not. We're just solving the equation. If we were thinking about a graph, then multiplicities would matter. But for this, it does not.
I haven't heard that word in so long.
Let's do, I'm bouncing around a little bit now. Let's do this one. This will be our 5D.
This will be our what?
5D.
Okay.
Oh, man. Oh, okay.
Alright.
Could we just do? We couldn't just divide those, right? Though, 'cause
Right. More than one term on the bottom, so we cannot just divide them.
that was standard. Can we
That is-
break it apart?
If it was only a single term in the denominator, we
But we
could.
couldn't do like the 3 at whatever 3.
So
Okay.
we have to multiply it by cotangent x plus 3 over
Okay.
tangent.
What if we just multiply our denominator?
Oh,
That's not how I'm doing it.
Those will go away. Then what?
Oh, so bring that other one over.
I like to keep my square term positive, so I'm going to subtract my cotangent.
Swoop and
Yes,
swoop.
it gets rain.
Sounds
I
like a
always-
great day to play baseball.
It always sounds like it's about to come right through your ceiling.
I
well,
know.
I mean, her ceiling is already leaky.
Is it?
This factor.
Positive or negative 3, positive 2.
It's, I don't know the sound.
And then we need to,
Divide by 2.
Like Mr. Green says.
okay,
Do the
we are doing all the answers between 0 and 360, so we don't need all possibles. We are in degree.
Oh, but this is a non-normal numbers.
So we get 3 halves and negative 1. Alright, in which quadrants is cotangent positive?
1 and 3.
We need a reference angle. Do we know when cotangent is 3 halves?
Nay.
No. So if we have to use the calculator,
We do 1 over tangent.
okay, this means
1 divided by 1.
tangent is the reciprocal, 2/3.
Oh, I understand.
Would we
So-
do second tan?
Yes, we
And
do
then
tangent over second tan, positive 2/3. And what mode should we be in?
Degree mode.
Degree.
Wrong mode. Oh, that's a big difference. Bless you.
I'm just going to leave this. We have 0.690067. I'm just going to say 33.69 degrees. So in quadrant 1, your reference angle is your angle. What do you do for quadrant 3?
You add 180.
Because you go to the 180 and a little bit further. So if we add 180 to 13.69 degrees. Okay, over here, it's negative. In what quadrant is this cotangent negative?
1 and 4. Or 2 and 4, rather.
Reference angle. When is cotangent 1?
Quadrant.
So the same thing as saying tangent is 1, so that is
Can't radical tool. It's 45 degrees. I couldn't get I had the finger down.
so 45 degrees in quadrant 2, 180 minus 45, 135. In quadrant 4, you do 360 minus 45, or 350. That unit circle can be very helpful.
So we're only doing reference angle because this is cotangent and not tangent.
I mean, we always do quadrant and reference angle, unless it lies on an x or y axis. The last few have been on the axis, so we didn't need it.
Yeah, that makes sense.
So I think I'm stopping here. We've really covered everything. I may do a couple problems tomorrow. We're going to kind of see how this is going. So I am going to give you homework. It is not due until, what's today? Today's Tuesday. It'll be due Thursday. I may potentially start the next section tomorrow. We're going to kind of see how things are going. So 11 through 23, every other odd, 31, and 39 through 55, every other odd. So I gave you odds, you